Welcome back to the gearbox rebuild. Here we are, back with a new gasket. This time I put the bell housing and gearbox together on the bench, like a normal person. Well, that was easy. This is the first of the high torque fixings. This bolt screws into the end of the lay shaft. Does that make it a bolt or a screw? The easiest way to tighten this bolt is to reach inside and engage two gears at the same time. Most of the nuts and bolts on the gearbox are Whitworth. If only I had a Whitworth set of sockets. I ordered 3 new seals for the selector shafts. I didn't realise that the reverse shaft is a different size. I replaced the seals not that long ago, so it doesn't matter. Just something to note. This is the reverse gear spring thing. The old springs are a bit crusty. I didn't try and replate them. I don't think it'll work very well. I did buy a couple of new springs, but they're probably not stiff enough. I'll leave them off for now and order Land Rover ones next time I'm getting other stuff. And now, the dance of the selector shafts. Getting these in without throwing something across the workshop and without reading instructions requires hard work and perseverance. I smeared the exposed ends of the selector shafts with copper-ease. This stuff is very persistent and will hang on a long time, and definitely slow down the rust. There is no gasket for the top cover, which is fine, because your driveway needs lubricating as well. But I do put a very light smear of grease in the join. This will nearly all squeeze out, but stay in the micro gaps. The grease won't readily mix with oil, so it acts like a bit of a buffer. If you decide to do this, Just be careful not to hydraulic any of the pins or bolt holes. This is the seal for the rear of the main shaft. That I mentioned in the last video is the wrong size. It's tight, but I figure, okay, fine. What's actually happening here that I didn't realise yet is that the inside diameter is slightly too small and the lip is being rolled over. Now, this is the devil nut. There is a special Land Rover tool for this nut. Don't judge me, I made this in a hurry a long time ago. It's a 32mm socket that lost a fight with an angle grinder. The nut needs to be tightened to 85 foot-pounds, which is a little difficult with the gearbox just wobbling around on the bench. You can see that in order to lock up the gears, I've removed the top cover again. And this is just after the point that I decided something wasn't right. The main shaft was just too tight, and it must be the oil seal. So after a bit of a fight, out it came. Luckily, the New Zealand Land Rover parts supplier had the correct seal in stock, so it only cost me a couple of days and a few dollars. Interestingly, they sent me an old-style metal encased seal. That's not what you typically get from the UK. Must be old stock. The metal seals can be a nightmare to get out, but they're much easier to install. The transfer case doesn't need rebuilding. I went through it recently, and there's no reason to dismantle it any further than necessary. The bearings on the output shaft are good, and they're impossible to remove anyway, so I'm not going to. And this nightmare mechanical sculpture? I'm not pulling that apart for fun. The first component to go back on is the speedometer drive housing. This is just a casting that holds the speedo gear and an oil seal. This is the oil seal that will definitely leak and drip from the transmission brake. But the casting also acts as a clamp to tension the bearings, adjustable with this pile of shims. It's a case of putting the shims in and tightening down the speedometer housing, and then adjusting the number of shims until the bearing preload is just right. It's all explained in the manual. I'm skipping all of that because I went through it recently. I'm putting oil between each leaf, just to help prevent rust. This is the speedometer drive gear, and this is the speedo gear itself. This little cover that goes over the four-wheel drive and low-range selector shafts is another source of leaks. Again, no gasket. But if you haven't fixed yours already, the lack of gasket probably doesn't matter because there will be a hole rusted through it anyway. Water gets in and rusts it out from the inside. So if you have yours off, stuff it with grease. And I also smear the shafts with copper ease. I'm temporarily installing the intermediate shaft so I can check the fit of the bimetal washers. I can't remember why I didn't replace these last time, probably just forgot to order them. This is the output flange for the front drive shaft. All of these splined output shafts use little felt washers. I didn't order any, but I have some stashed away. Buy a bunch of them if you own a series Land Rover. They're used in about half a dozen places on the vehicle, which means you'll go through about 1 dozen per year. The front output flange nut needs to be tightened to 85 foot-pound, but I'll do that later at the same time as the rear output nut, so that I can hold each of them still from the opposite end. The service manual tends to call for greased gaskets between aluminium parts. I normally grease the thin paper gaskets anyway, but I make sure to keep the smearing light, especially in critical structural joins like this. There are 3 fixings on the outside and 3 on the inside. Well, actually there are 5 on the outside if you count the 2 holes higher up. These are the 3 metal lock nuts that fix through from the inside of the transfer case. If through normal use, you have to separate the transmission to get the gearbox out in a paddock, these are the 3 nuts you will need to find. They are obvious once the intermediate gear is out of the way. These nuts are tightening onto studs in aluminium, so I don't want to go crazy with the torque. But they are sandwiching a squishy gasket. Because they are not accessible later, I tighten them tight and then leave them to settle and squeeze for half an hour or so, and then give them a final tweak. Now that the gearbox and transfer case have become one, I reinstall the intermediate shaft finally. I think you can probably put the gearbox and transfer case together with the intermediate shaft in place, but it's easier with it out of the way. This copper washer that threads onto the plugs has a little piece of gasket in it. It's the type you want. I've ordered washers from the part number before, and sometimes they come as plain solid copper washers. I think this compressible type is far less prone to leaking. This is what you get in the Britpart gasket sets, but check if you're ordering them separately. And now, perhaps a series Land Rover's leakiest leak spot, the transfer case cover. The gasket is chunky thick, and basically you're relying on gasket compound to keep the oil in, which it won't. One of Land Rover's greatest features, the power takeoff cover. There is a corresponding clear hole all the way through to the rear of the vehicle. So swap this cover out for maybe a rotary hoe, or drive a concrete mixer, perhaps a table saw, or run line shaft machinery from the back of your truck. This is also where an overdrive slots in. On that note, if anyone in New Zealand has an old ferry overdrive bouncing around in their shed, please get in touch. And another fairly unique Land Rover feature is the transmission brake. This is the hand brake for the vehicle. It's a fifth drum, independent from the rest of the brake system. Just a quick note that this transmission brake gasket doesn't come in the gearbox gasket set. This is the rear output flange. This often leaks where it runs in its oil seal. That's the drip on the bottom of the transmission brake. The flange itself is one of the few parts that you can't buy new. You can see I have installed a speedy sleeve on it in the past. There is one more thing to deal with. You may remember I mentioned this one time when I ripped the gear lever off. Well, here is the aftermath. Don't judge me. This was welded while lying in the footwell on the side of the road, with no good way to clean the crud off, no fancy welding helmet, and no clamps. Anyway, the weld has stood the test of time, so back off, Jody. And of course I replaced it with a new gear lever. But I never used the new one, because the replacement versions suck. See how the end of the original one is like a steel ball with an O-ring? Well, the newer versions look like this. A turned shaft with a big rubber bung. I guess it's easier to make. The problem is that because of the squishiness, it can squeeze out through this gap. So you accidentally go from reverse into nothingness, stranded with no gears. And that's an awkward situation to be in front of a bogan in a Toyota at the supermarket car park. So I'm going to quickly see if I can easily transfer the old end onto the new lever. Let's see if I can unthread it with an easy out. These never work. Whoa, that was easy. Turns out I'm not the first guy in here. Someone has already modified this by drilling it out and bunging a broken lever back in. At this point, I decided to stop romping a dead horse. I'll try and find a better replacement lever before I waste a day or two trying to make this old one work. And that's about it. Back in a couple of weeks with the engine.